Okay, good morning class, right? Okay, so today we continue on chapter 6, okay, generating electricity. Okay, but before that, next class, okay, we will discuss the tutorial that I give for chapter 5. Okay, so I hope you already answered the tutorial. Okay, so we can discuss later. Okay, so now we go to the next subtopic. There is a type of current. Okay. Okay, so for actually we already last week, right? Okay, we already learned about the sources of energy. So there are two type of sources of energy: the renewable energy sources. Okay, so what's the meaning of the energy renewable energy sources, and also the example, right? And the non-renewable energy. Okay, what's the meaning of the non-renewable energy, and also the example, right? And then the renewable energy sources and what type of energy that being produced, okay, by the renewable energy sources, right? And also the generator. So what is the function of the generator here? So the generator is the device that used to generate electricity. Okay, in the generating electricity. So this is actually the induced current. So I hope you still remember, okay, how to produce the induced current, right? You have to cut the magnetic fields lines, okay? Then you can produce the induced current, right? Okay, so for this one also I already show you the video, okay? Yeah, I mean there must be a movement, right? Okay, there must be a movement of the wire or the movement of the magnet, okay? So it can cut the magnetic fields, okay? All right, and then also we already learned about the power station. Okay, so there are several type of the power station. So this is the thermal power station, okay? All right, and what is the conversion of the energy from the chemical to the electrical energy? And also, we already learned for the power station that using the solar energy by solar panel. So, what is the energy conversion? Right, and also for the hydroelectric power station. Right, and the next one is the wind energy. Okay, the power station that using wind energy. Okay, and this one using the nuclear fuel, okay, by using the radioactive substance, right, like krypton, plutonium, okay. So this one they will produce a lot of electrical energy. Okay, and this one by using the biomass, okay, we use the plant, by the agriculture or the plant residue, okay, and then we burn it, okay, and we produce, we heat the water, and the water will change to steam, okay, and the steam will turn the turbine, and the turbine will turn the generator, so generator will produce the electricity, okay. So this is for the biomass. All right, and then yeah, so this is the what we will learn today, okay, about the current, okay. So there are two types of electric current, okay. So the first one is the direct current, okay. So the first one is a direct current here. So what does it mean by the direct current? So the direct current is the electric current that flows in one direction only. So like as example here, let's say if I have the dry cell, right, or battery, okay, and I have the emitter here, okay. Okay, so you already know, okay, you learn on form 2, right, the electricity chapter. Okay, the current flows from the positive terminal to the negative terminal. Okay, so means the current is only can flows from the positive terminal to the negative terminal, so only one direction only. So this we call it as a direct current, or we call it as a DC current. Okay, so the emitter will reflect this way, okay, to the right, okay, to the direction of the current. Okay, so this is an example of the direct current. So you can see it can only flows in one direction only. Okay, so the example like TV remote control, wash, okay, torchlight, okay, and the direct sources, direct current can be generated, okay, from the various sources, okay, such as a battery, okay, solar cell, and also the accumulator. So this one, the accumulator, the one that we use in the car, okay, the car battery. Okay, so they produce the direct current, means it only can flows in one direction. So let's say for the battery, I take example for the battery, it only flows from the positive to the negative terminal. Okay, but how about the alternating current? So the alternating current is the electric current that flows in constantly reversing direction. Okay, so let's say if I have sorry. Okay, so this is a symbol for direct current, right? For the battery. Okay, for the alternating current, the symbol is like this. Okay, so this is the symbol for the direct current. So let's say, sorry, for the alternating current. So let's say if I've connected the alternating current, okay, to the, right, let's say to the generator, straight to the galvanometer or something. Okay, so what happened here, right? What happened here? Because it says the electric current that flows in constantly reversing direction, right? So the first cycle here, okay, the first cycle here, it will flows from here to here. Okay, from here to here. So after it complete, okay, after it complete one cycle here, okay, it will move in the opposite direction. It will move in the opposite direction, in the reverse direction. So the first time it moved in this direction, okay. So after it complete, okay, in one circuit, okay, it will move back, okay, from here to here. Okay, so it will be like this one will be happening, okay, all the time, okay, from here to here, and then come back here to here, and then again here to here, then again here to here. Okay, so this is the alternating current. It can keep changing the direction. Okay, first one from here, okay, maybe the first one is like in a clockwise direction, right? And then after that it move anti-clockwise. Okay, after it complete one circuit, okay, after it complete one circuit, then it reverse back the direction. Okay, so this is the alternating current. So that's why it said the electric current that flows in constantly reversing direction. Okay, so the changes in direction of the current flows are caused by the change of polarity of intermittent voltage. Okay, so means it's like this one, the first one, maybe this one is positive, this one is negative. So it flows from here to here, right? Because you already know the current flows from the positive to negative terminal, right? So maybe the first time this is the positive terminal, this is the negative terminal. So it move from positive to negative, right? And then after it complete one circuit, right, it changed the polarity here. So let's say this one should be positive and this one negative. So it move from here to here. Okay, so if we keep change the polarity here, so that's why it move in the, it always change the direction. Okay, so that is for the alternating current. Okay, so this is the example, okay, of a device that use the alternating current. So the refrigerator, the microwave, okay, the washing machine, right? Okay, CRO. Okay, so what is actually a CRO? So the CRO is the electronic device that is used to show the difference in the shape of graph, okay, direction of current, and also the voltage change for direct current and also alternating current. So because for the direct current and for the alternating current, they have their own graph. I mean the graph is not same for the direct current and also for the alternating current. So I will show you, right? I will show you a video first, okay, about the CRO. Then we go further about this one, right? Okay, wait for a moment. All right. Okay, so this is the CRO. Okay, actually there are many types of CRO. Okay, so this is one type of CRO. Okay, so this one they already connect to the DC power supply. So you can see here this is a DC power supply. So they already connected to the DC power supply. So means they only this one they can just decrease the voltage here, increase the voltage here, okay, by using the DC power supply. Okay, so we see what happened, right? When it's switch on the DC power supply, so you can see what happened to the CRO here. So this one is a display. So you have to see here, okay, at this one, the screen here. Okay, right? So this one when it didn't put any voltage to the CRO. So you can see here when you increase the voltage, right? Okay, when you increase the voltage, okay. So when you increase the voltage, the graph, okay, the graph, okay, you can see it changed the position. It's going up, right? So this is actually the graph for direct current. Okay, this is the graph for direct current. Okay, so what is the graph for the alternating current? Okay, so this is the graph. So this one is connected to the AC power supply. So what I just want you to see is actually this type of shape of the alternating current. So this is the shape of the alternating current. Okay, so you can see there are peak here. Okay, it's like a mountain there, right? So this is actually alternating current going down, going up. Okay, so this is the alternating current graph. Okay, so remember the one, the straight line, right? The straight line. Wait, okay. So this one is the direct current. Okay, and for this one is the alternating current. Okay, so some of you must wonder, right? Why some going up, why some going down, right? So what happened is actually, okay, is actually, remember I said just now, right? The alternating current, it can change direction. Okay, it can change direction. Okay, so let's say the first one, this one is positive and negative. It can change the polarity, right? So let's say the positive and negative. So this is the first cycle. Okay, so the first cycle from here to here. Okay, so this is the graph. Okay, so this is the graph. All right, and then after that I choose another color. So and then it will change direction, right? So after it complete one cycle here, it will change direction from here to here, right? So now when it change direction, okay, so the graph will be go down like this. Okay, and then after that change direction again. Okay, so the graph will move up again. Okay, and then after complete one cycle, it change direction here. So now it become the red one, like that. So actually, why does the graph keep changing like this? Because of the changing in the position, in the direction of current. So the first cycle is the blue one. After it complete one cycle, it move in different direction. So it will become down here. So means it's like moving in the opposite direction. So that's why the graph become like this. Okay. So this is for the alternating current. All right. So now we see, right, how to use an oscilloscope, okay, for the CRO. Okay, I show you a video first. Okay, so this is what type of current? Can I ask someone? So this is what type of current actually? The one that you see here in the display. What is the type of current, this one? Anyone? Yes, very good. Alternating current. Okay, so the direct current, the straight line one. Okay, very good, Pak Bandit. Okay, so how you want to see use the oscilloscope? Okay, this one they use with the alternating current. Okay, they use with the alternating current. So you can see there is a lot of knob here. Okay, this one you can change the position, the voltage. Okay, and then you can set the time here. Okay, so this one they already connected to the AC power supply. Right.
Signal.
Okay, so for this one we just skip first. Okay. Actually, I want you
Ensure
to
that the input
see to
signal
read
is
the
displayed
voltage.
correctly. Ensure that the trigger is set to the same channel. The VAR dial is used to vary the gain of mode by turning the dial clockwise.
Okay, okay. So this is one that I want you to see, the measuring the voltage. Okay, so how you can measure the voltage? Okay, how you can measure the voltage by only see the graph here. Okay, by using the graph here, how can you measure the voltage? Okay, so actually there is a button here. You can see the volts here, right? Volts per division. Okay, so what does it mean by volts per division? Okay, so this one small box here, okay, so this one small box here, we call it as a division, right? As a division. Okay, so let's say if I want to calculate from here to the peak, right? Okay, to the peak of the graph. So 1, 2, right? So 2.8, I think. Okay, so this one because they have a small scale here, okay, but maybe you cannot see it clearly. Okay, so this is 1, 2, okay, and then this one is 0.8. So you get 2.8 division like that. Okay, so 1, this is called as 1 division. Okay, so let's say if I want to measure the peak of the graph, okay, so the peak of the graph is from here to here. Okay, from here to here, this is the peak of graph. Okay, here to here is the peak of graph. So this one, what is the division? How many is the division for the peak of the graph? 1, 2, okay, and then this one is 0.8. Okay, so this one you maybe cannot see it clearly. Okay, so 2.8 division, right? So this is like 1 volt per division means, what does it mean by 1 volt per division? So 1 volt per division, it means for 1 division, it is equals to 1 volt. Okay, so that means this one small box here, okay, 1 division here, we call it as a 1 volt. It's equals to 1 volt, right? So let's see the video. Okay, now,
Set of controls on the left of the oscilloscope vary the
okay, so this is the one that control like the voltage, how you want to like, you can move the graph here, right? So later you will see. Okay, so this is actually the part that we move the graph here.
position and scaling of the vertical or voltage axis of the signal displayed on the oscilloscope screen. The vertical position dial is used to change the position of the signal's display relative to the grid. It does not.
Okay, so this one, the position means the graph can move up and down. So why you need to move up and down? So maybe you can adjust it, like, because to make sure that the graph is really you can read the graph easily. Okay, so you can move the graph up and down according to the grid given. Okay, so this is the position, you can move up and down.
Alter the actual input signal. The volts per division dial changes the scale of the displayed signal voltage.
Okay, so for this one, it changed the scale. Okay, so this one they put 1 volt, right? This one you can see it pointed to the 1 volt per division. Okay, so means one box here is 1 division. Okay, so later you can see when you change the knob here, you can see the graph also become different. Okay, the size of the peak also become different.
Can be used to ensure that the entire
See?
range of the signal is displayed on the screen.
So for this one, is 2 volt per division. So means for 1 volt is 1 division is 2 volt. Okay, just now when it's pointed at 1 volt per division, right? So mean 1 division 1 volt. So now it goes to 2, right? So means 2 division per volt. So that means 1 division is equals to 2 volt here, right? So I repeat again, just now 1 volt per division. So means for 1 division is equals to 1 volt. Okay, so let's say it changed to 2 volt, means 1 division here is equals to 2 volt, right? So that's the difference. Okay, so that's the difference. So you can see you can change here. So it depends on the on you which one you want to use, and it's easy for you to read the voltage. Okay.
To calculate the peak-to-peak voltage of the signal, the number of divisions between the maximum and minimum of the signal must be counted. This value, multiplied by the volts per division setting, gives a peak-to-peak voltage.
Okay, so for this I will show you right. So what information that you can get, right, from the CRO. So there are two type of voltage that you can get. The first one is the peak voltage. Okay, from the CRO you can get two type of voltage. The first one is the peak voltage. Okay, and the second one is the peak to peak voltage. Okay, the first one is the peak voltage, the second one is a peak to peak voltage. Okay, so how you want to calculate this one? So I give an example. Okay, so you can see here in the video just now, okay, you can change the voltage here, right? So what is the division for one division is equals to what, right? So you can change here. So for this one, let's say it puts 1 volts per division, means one box here is equals to 1. Okay, so from my diagram here that I already put here, so you can see here how many division here, my peak voltage, how many division here, anyone? Oh, sorry, you didn't see my screen. Sorry. Wait for a moment. Okay. So this is a peak voltage, right? And this is voltage peak to peak. Okay, peak to peak, this is the peak voltage. So there are two types of voltage you can get from CRO. The first one peak voltage, the second one peak to peak. So let's say if I use the division here, right? Let's say if I use the division here, I use 1 volts per division, right? 1 volts per division. So that is my scale. So 1 volt per division. Okay, so can I ask you how many division for the peak voltage here? 2, right? So from here, I already tell you this one means 1 division is equals to 1 volt. Okay, and you already answer me this one is 2 division. So if 1 division equals to 1 volt, if 2 division is equals to what? How many volts? 2 volts. Okay, so that's the answer. That's how you want to calculate the peak voltage. You have to know that actually 1 division is equals to what? So let's say if I change to 2 volt per division. So if 2 volt per division means 1 division is equals to 2 volt. So for this one, the peak voltage, how much is the peak voltage here? 4 volt. Yes, very good. So 2 division is equals to 4 volt. Okay, so that's how you want to read the peak voltage. You have to know, okay, what is 1 division is actually equals to what? Okay, how many voltage? So from where you can get the info, you can get from here, right? So you can see 1 volt. Okay, so the next one, okay, so for the next one, how you want to calculate the peak to peak voltage? Okay, so from peak to peak means you have to calculate how many division is there from here to here. Okay, from here to here, how many divisions? Okay, 4. So this one we already calculate 2 volt, right? So for peak to peak, okay, peak to peak, so you already know it has a 4 division, okay, and I already told you for 1 volt per division means if 1 division is 1 volt, or if 4 division means 4 volt. Okay, yes. So that's how you want to calculate the peak voltage and the peak to peak voltage. Okay, from the CRO. Okay, so that's the info you can get. Alright, so for the next one, you can also calculate the frequency. Okay, so how you want to calculate the frequency? Okay, so how you want to calculate the frequency for the, at first you have to know, okay, sorry. So you have to know what is the formula for frequency, right? So anyone, do you know what the formula for the frequency? This one you already learned on in form 1. So what is the formula for frequency? What is the formula for frequency? Frequency is F equals to 1 over T. Okay, so F is a frequency, T is what? T is a period. Okay, and the unit for it is second. And what is the unit for frequency? Okay, so the unit is hertz. Okay, or we put sometimes Hz. Okay, the symbol for hertz is Hz. Okay, so that's the formula for frequency. Okay, so how you can calculate for frequency from the CRO? Okay, so let's see the video first. Okay. Okay. Alright, so measuring the period and frequency. Okay, so just now you can see here, this one is actually to control the voltage, right? And you can see it can move the position of the graph up and down like that. Okay, okay, for the in the middle here, sorry, in the middle here, so this one is we use to control the time, okay, the time of the graph here. Okay, so let's see, okay, what is the position, what is the function of position here? Okay, so just now for the voltage, right, it goes up and down like that. Okay, and but for this one they can move left to the left and right. Okay, for the voltage it can move up and down like that. Okay, this one for the horizontal they can move, okay, left and right. Okay, so let me show you again. See, it can move. Okay, so it depends on you which one, which side you want to move. Okay, and actually before that, okay, before that, okay, actually this graph, okay, this graph, okay, so the y-axis is in the voltage unit, okay, and for this graph is actually time and is actually the unit is in second. So this one is actually, let's say I draw a graph like this. So this one is the y-axis. So this is the voltage and this is the time. Okay, and the time is in second. Depends the second or in the millisecond. It depends on this one, on the knob here. Okay, so for this one also you can change the time. Okay, so what is the one division? One division is division here is equals to what? Right? So you can change here. Okay, so let me, okay. So this is the time here. You can change the time. How one division here is equals to what? For the x-axis. Okay, just now we change for the x-axis, right? Okay, so for this one we change for the value of the x-axis. So one division here is equals to what? So this one you can see, okay, ms, right? Okay, you can see here the symbol ms. So this one is actually the unit is in a millisecond. Okay, so from here until here, okay, until here, all the unit is millisecond. Okay, all the unit in millisecond until 10 here. Okay, then after that, from here to here is a microsecond, right? So here is millisecond. Okay, starting from here is a microsecond. Okay, so you need to know which part of it that you choose. So let's say for this one, okay, it choose 10, right? So 10, okay, 10 millisecond. Okay, because it's still on the scale of millisecond. So for this one, it choose 10 millisecond. But you can change, right? You can change the time that you want. Let's say you want to change to 1 millisecond. So you just pull the knob to here. Okay, they change to here, right? The pointer to here. So you will get 1 millisecond. Okay. So that is how you want to know what is the division for each division. What is the value of the each division on the x-axis? Just now we learned in y-axis, right? So this one, how many division? 1 volt, right? Like that. So for this one is the time you see here. So this one they already changed to 10 millisecond. Okay. So using the diagram just now. Okay. Let me clear it first. Okay. So we know if you want to calculate frequency, you must have the period, right? So how I can find the period from this graph? Okay. So the period is actually the two semicircle here. Okay, two semicircle here is equals to one period. Okay, so this one is actually equals to t, and then another one here is actually t also. Here is another t. Okay, so every two semicircle is actually equals to one t, one period. Okay, so for this one, okay, what is the period here? Okay, so let's say if I take the value, okay, the value for the scale here is, let's say I put um 10 millisecond per division. Okay, 10 millisecond per division. So what does it mean by 10 millisecond per division? One division is equals to 10 millisecond. Milli, what is the prefix value for milli? Anyone knows what is the value for milli? For kilo, 10 power of 3, right? How about milli? 10 power of what? Anyone still remember? You learned in Form 1. What is the milli? What is the value for milli? 10 power of what? Yes, very good, Junyuan. Right? So 10 power of negative 3. Okay, so means that for one division is 10 times 10 power of negative 3, not 10 power of negative 3 only. Okay, 10 plus 10 power of negative 3. 10 is the value here. Milli is the 10 power of negative 3 here. Okay, so I change the value of milli here. Okay, and this one is the magnitude, you cannot change lah. Right, so 10 plus 10 power of negative 3. So what does it mean? This means that this one division here, right, for one division here is equals to 10 power times 10 power of negative 3 for one division here. Okay, so for this one, okay, so for this one they got, this is one division already and this is two division already. But if you see clearly, okay, it means it move like one more, right? This one we get extra, right? Okay, like 0.2 here. Okay, 0.2 here, and this one is also 0.2. Okay, in more than like this is two division already, but you can see it got like extra here, right? So this one is 0.2, this one is 0.2. Teacher, how do you know this one is 0.2? Because this one is a one division, right? Okay, and you can see here they got another 5 smaller scale here. So 1 you divide by 5, you got 0.2. So every the small scale here is actually equals to 0.2. So 0, 0.2, 0.4, 0.6, 0.8, and then you got one division. Okay, so you can see they got one extra 0.2 here, and this one also got extra 1 0.2 here. So two division, okay, plus 0.4. So you got 2.4 division, right? So 2.4 division, so how much for 2.4 division? If one division is 10 times 10 power of negative 3, so 2.4 division is equals to what? Can you give me the answer? Do you have a calculator with you? Try to calculate. Do you know how to calculate? Do you know how to calculate for this one? You don't know. Okay, so I explain again. 0.024. Okay, so let's see whether it's correct or not. Okay, so this one you already, can you understand how do I get 2.4 division here? Can you understand how do I get 2.4 division here? Hello class, can you understand how do I got 2.4 division here? Ticking, paying. Do you understand how do I get 2.4 division? Teacher, can please repeat? Yes, okay. Just tell me if you don't understand. Okay, so here let me make it larger first, the diagram. Right. Set this. Okay, so this is the diagram, right? Okay, so for this one, okay, for this one is actually I put like, okay, never mind. Okay, so the first one we just try to calculate the division of the division of the graph. Okay, wait, I try to erase this one first. Okay. So for you to calculate the frequency, okay, F is equals to 1 over T. So this is the formula, okay, and you need to find the period here, okay. So how you want to find the period from the graph, okay? So from the for the period on the graph, how you want to find? You need to calculate, okay. You need to calculate two, okay, two semicircle here, right here. The length of the two semicircle here. So these two semicircle is equals to 1t. Okay. So this one is actually another t and this one another t. Okay. So this is actually the period here. Okay. So from here is a period. Okay, so how you want to know how many division is here? Okay, so this one you can see is already one division, right? From here to here is one division. Okay, so this is one division from here to here, one division. Okay, and then from here to here, another one division. Okay, so from here to here, another one division. So actually you already got two division. Okay, but from the graph, You can see they got extra here, right? One division is from here to here, but they got extra here. So this one is 0.2. How do I know this one is 0.2? Because this is actually equals to one division. Okay, so inside in the one division, there's still they keep like there's a smaller scale here, right? So this one is 0.2, 0.4, 0.6, 0.8, then you got 1. Okay, so this one, the smallest scale here is actually equals to 0.2. So here is already one division. Okay, and then you got another extra 0.2. So this one is 1.2 division. Okay, 1.2. If you want to calculate one by one also can. 0.2, 0.4, 0.6, 0.8, 1, 1.2. Okay, so from here to here is 1.2 division. Okay, and then from here to here, okay, so this one already got one division, right? But they got extra 0.2 here. So you have to add, okay, so 1 plus 1 plus 0.2, you got 1.2. So from here to here is 1.2 division also. Alright, so what is the total division for 1t here? 1.2 plus 1.2. So you will get 2.4 division. Is it okay? Okay. So now you got 2.4 division. So let's say if I put my knob here, I put here. So this one is 10, right? 10 millisecond. So what does it mean by 10 millisecond? Teacher, how do you know millisecond? You can see the unit here. And you already said from here to here is millisecond. Okay? So from here to here is millisecond. And 10 is actually at the millisecond. At the range in the millisecond. So this one is 10 millisecond per division. Right, so you can see here time per division. So means 10 millisecond per division. So what does it mean by that? 10 millisecond per division. So means for one division is 10 millisecond. Okay, that one can you understand? Is it okay? Alright. Junyuan, Kester, Pak Vandip, Ziking. This one can you understand? When he said 10 millisecond per division, so how teacher get? Teacher read from the note there. Okay, so 10 millisecond per division means one division is equals to 10 millisecond. Alright, okay, and then, so let me make it smaller. Okay, after that, one division is equals 10 millisecond, right? So you got how many division just now? You got 2.4 division, right? So if 2.4 division, how many second is that? Okay, so let me put again, one division is equals to 10 millisecond. So milli I change to 10 power of negative 3. Okay, so I got 10 milli is 10 power of negative 3 here. Okay. Okay, so this one is the value. Okay, I changed the value of milli to 10 power of negative 3. So one division is equals to 10 times 10 power of negative 3. Okay, so mine is 2.4 division. 2.4 division. So if 2.4, how many millisecond is that? Okay, so means you have to multiply, right? 2.4 times 10 power times 10 power of negative 3. Right? Okay, so how you want to calculate that one? Okay, so use your calculator. 2.4 times 10, okay, exponent, okay, negative 3. Okay, 2.4 times 10, this one I put change into exponent negative 3. So what do I get? 0.024. Just now someone answer, right? The answer is correct. Junwan, I think. Yes. So that's how you want to calculate. Okay. So first one, you try to calculate how many division is that. Okay. And then you check your CRO. Your one division is equals to what? So if your one division is equals to 10 millisecond, so you change first your milli to 10 power of negative 3. So 1 division is equals to 10 times 10 power of negative 3. How teacher get 10 power of negative 3? Is actually the value for the prefix of milli. Okay, this one you learn in form 1. Okay, so 1 division is 10 times 10 power of negative 3. So mine, yeah, the one that we calculate just now is 2.4, right? So if the 1 division is equals to 10 power of 10 times 10 power of negative 3, so what is the time for the 2.4 division? So you just times 2.4 times 10 power times 10 times 10 power of negative 3. Okay, so you just use calculator here. Okay, 2.4 times 10 exponent negative 3. So you got the answer 0.024. So this one is actually the period, the value of t. Okay, so we still not finished yet. We have to substitute in this formula. So 1 divided by 0.024. So what is the answer here? So to find the m of the, yes. You need to look back to the CRO. What is the setting that you use? Okay, say if you're setting here for this video here, they change to you put 10, right? So it means you know your value for the one division for x axis is 10 millisecond. Okay, if you change to 1, so it become 1 millisecond. It's depend on you. Okay, which one you think that is easier for you to read. Okay, the scale. All right. Okay, so what is the frequency here? This one that I calculate is actually the t. So what is the frequency here? 1 divided by 0.024. Try to use your calculator. 1 divided by 0.024. So you got the answer 41.67. Correct? Did you get the same answer like mine? So 41.67 hertz. So that's the unit. Okay. So that's how you want to calculate the period, frequency, and also measure the voltage. Measure the voltage. You use the vertical one, the y-axis. Okay, the division for y-axis. If you want to calculate the frequency, of course you need to know the period first. You use the x-axis here. How many division? So what is the period here? How do you want to find one period? You just find 2 semicircle. Then you just calculate what is the length here for 2 semicircle. Okay. Is there any question you want to ask for the calculating part for the peak voltage, peak to peak, and also the frequency before I move on to the next slide? No. So are you really clear about this one? Others? That very quiet one? Any question you want to ask? Okay, so this one we already learned. Okay, so this one already done explain. Okay, so this is the CRO. So this now we see the different type of CRO, right? So this is also CRO. So this is the part of CRO. Okay, the Y gain node. Okay, the Y gain is actually for the vote. You can see here is for the vote. Okay, and this one is the Y shift node. Actually, the one that the position you can change up and down, right? Just now you already see. Okay, and then this one is the direct current, the alternating current switch. So if you want AC, you just change to AC. If it's DC, you just pull it to DC. Okay. And then this is the X shift node. Okay, this one to move the graph right and left, the one that I show you in the video. Okay, and then this one is the intensity control node. So you can change the intensity, increase the intensity so the graph become brighter. Okay, and this one is to focus the control node. This one is for the sharpness. Okay, the sharpness of the graph. And this one is a time base. This one is actually you want to calculate the frequency, right? You want to find the period. So this is the time base here, right? So you have to see what is the scale that you choose, right? So it's the function. I already explained this now. Intensity to control the brightness, focus to adjust the sharpness of the graph. Okay, the time base to control the movement. Okay, and then for the Y gain knob, okay, this one is to change the magnitude of height. This one is to adjust the position, okay, vertically up and down. Add shift knob to move left and right or horizontally. And this one is actually to select it according the type of input received. So if you put direct current, just change to direct current. Okay. Um, Okay, so this is the uses of CRO to measure potential difference. So I already teach you how to measure the voltage here. Okay, and this change over time. Okay, so this is the this is the alternating current, and this one is a direct current. Already also I showed you in the video. Okay, and this one is a negative DC. Okay, so they say if you put the wrong terminal, it will become negative part like that. So the voltage to be measured must be connected across the Y input. Okay, Y gate knob. Okay, this one a microscope is connected to this one a microscope. This one is actually the microphone. Okay, wrong typo. Okay, so this one is a microphone. Okay, so this one just now you want if you the one that we used the example just now. I use example. You want to calculate the time. I use the example for AC current, right? So either the AC current, you also can use the microphone. Okay, to calculate the time. Okay, time interval. Okay, so for now, I use the alternating current as the example. So you can use also the microphone. So let's say you connected the CRO to the microphone, and let's say you start to talk. Okay, so you can see there are two peaks here, right? Two peak of graph here. Okay, so you want to measure the time here is measure from peak to peak. Okay, so from peak to peak, so how many box here? 1, 2, 3. So then you multiply with the time per division. So let's say if like 10 millisecond per division. Okay, so sorry, 10 millisecond per division. So this one is 3, right? 1, 2, 3. Okay, from peak to peak, from here to here. So there are 3 divisions. So one division is 10 millisecond. If 3 division means 30 millisecond. Okay, so you can use that one also for the CRO. Okay, so 10 millisecond. So that's the interval. So 10 millisecond means 10 times 30 plus 10 power of negative 3. So if I change to the milli, the prefix, okay, the prefix for milli. Okay, so this example, they use a 5 millisecond per division. Okay, so the sound energy change is converted to the electrical energy and we shows as a pulse here. So the distance is yeah, it's fixed. It's fixed. Yeah, it's fixed. It means it's always one division per 10 millisecond like that. Okay. Okay, so the distance between the two pulses is 3 division. So 3 times 5 millisecond means you got 15 millisecond. Okay, because one division is equals to 5 millisecond. If 3 division, 15 millisecond. 3 times 5. Okay, so 50 millisecond. Okay, so that is how you want to calculate the time interval. Okay, so it's the same like the one that I use is actually for the alternating current. But this one they use a microphone to generate a sound, then the sound will change to the electrical energy. Okay, so to wave This one also I already explained. This is a DC voltage. This is the AC voltage. Okay. All right. So we finish for generating electricity. Okay. So after this, we goes to the transformer. Okay. So I think I will stop until now. Okay. So if anything, you can text me. Okay. So thank you, class. Right. So I see you on tomorrow, I think. Do you have a tomorrow? Yeah, yeah. Tomorrow we still have class. So we continue tomorrow for the transformer and we discuss for the tutorial, right? Teacher, can you post? Yes, I will post on YouTube. Okay, you can see my channel there. All the video that I teach, okay, is on the YouTube. Okay, you can go. I already put the playlist there. Okay, for science form P, so you can see the video there. The PowerPoint. You want the PowerPoint? If you want the PowerPoint, I will send you the soft copy in the Google Classroom. Is it okay? Okay. So thank you, class. Okay. See you tomorrow. Okay. Take care. Bye. Welcome.